Hello, welcome. Thanks everyone for coming here and joining us this afternoon for the conversation, Making Sustainable Design from the Classroom to the World. My name is Roi Salgueiro. I am a lecturer at the MIT Department of Architecture, and I'm also the curator of the Morningside Academy for Design, MAD, who is organizing this event together with the Boston Design Week. So I will introduce the event, but before doing so, I would like to read the land acknowledgement that represents MIT's commitment to the indigenous communities that historically have lived in this area. We acknowledge indigenous peoples as the traditional stewards of the land and the enduring relationship that exists between them and their traditional territories. The lands which MIT occupies are the traditional and ceded territories of the Wampanoag Nation and the Massachusetts peoples. We acknowledge the painful history of genocide and forced occupation of these territories, as well as the ongoing process of colonialism and dispossession in which we and our institution are implicated. Beyond the stolen territory, which we physically occupy at this very moment, MIT has long profited from the sale of federal lands granted by the Morrill Act, territories stolen from 82 tribes, including the Greater and Little Osage, Chippewa, and Omaha peoples. As we honor and respect the many diverse indigenous people connected to this land from time immemorial, we seek to indigenize our institution, offer space, and leave indigenous peoples in more empowered positions. So, for those of you who still don't know us, MAD is a quite recent initiative. We launched our activities actually here at the MIT Museum in October 2022, so we are a little bit less than 1 year operating publicly. And we are an interdisciplinary hub for design at MIT, fostering design education, research, and entrepreneurship. Our aim is to educate future generations in design, foster design innovation, and encourage entrepreneurship to empower individual and collective problem-solving capacity around the globe. So one of our key goals is actually to, is this not working? No? Now better? Oh my goodness. Okay. Sorry about that. So I'm not going to repeat everything, so let me start at this point. So one of the things that we are trying to do is to foster cross-disciplinary conversations around MIT between different faculty, students, research groups, centers, etc., which is actually what we are trying to do also like this afternoon with the conversation that we are about to start. So this is what we plan to do today. We would like to make a contribution to Earth Day and also to the Earth Month. As you know, like Earth Day was last Saturday, April 22, organizing a conversation, bringing different voices which are working on issues related to sustainability here at MIT, people that is like working on academic environment, but also has a potential to actually impact the world out there, like either by testing or by actually developing their work and implementing it in external contexts. So we have brought three teams, three representatives of different teams to show what their work is. As I said, MAD is a pretty recent initiative. So actually because of that, there are like many occasions in which we do things for the first time. And this is the first time in which we organize something with the Boston Design Week. So we would like to thank the Boston Design Week for their collaboration, for their support. Yeah, this really needs to be closed. For their collaboration, for their support, for their patience as well in working with us and starting to organize like this event. Of course, we would like also like to encourage you to have a look at their website. The Boston Design Week is organizing like several events. They started on April 25 and they will continue until May 7th. With different events related to design all around the city. We would also like to thank the MIT Museum. We have been collaborating with the MIT Museum actually since our beginning. We launched MAD here on last October, as I said. And throughout like these months, we have been collaborating with them repeatedly. So this is a venue that we like very much, and in a way that we find is like the perfect venue to talk both about design and technology. So we would like to thank the MIT Museum team. We would like to thank in particular Catherine Gorge, Jacob Morich, and Caitlin Self-Harris for their support during these last weeks. So this afternoon, in particular, we will have 3 main participants, Norhan Bayomi, Maria Aguiar, and Dan Sweeney, and we will have one moderator, Tony Hu. And I would like to thank them all for their presence here. So in particular, Tony will be moderating the event. He is the director of MIT's Integrated Design and Management Master Program, which helps develop students across design, engineering, and business domains into innovative leaders. As an entrepreneurial leader with 25 years of experience as head of product design and development at small companies and large corporations, Tony has brought more than 200 customers' products to market globally, including electronics, appliances, toys, and sporting goods. As an inventor, he has licensed 22 products and been awarded 18 patents. As a teacher, he is a rarity. He's an engineer with a deep background in design and business who loves sharing his holistic approach to product design with students. He has taught product design at MIT and Stanford for 13 years prior to joining the IDM program. He earned his Bachelor of Science in Electrical Engineering at MIT, conducting research at the Media Lab, and his Master of Science in Product Design from Stanford. So please join me in welcoming Tony Hu, who will lead the event from now on.
All right, thank you. Thank you, Roy. Thanks, everybody. Great to see you all. Happy Earth Day. Happy Boston Design Week. It's nice to see some familiar faces out there, too. Yesterday, I was having a nice chat with the director of the Morningside Academy for Design. That's John Oxendorf. We were having a nice chat outside, getting some fresh air, talking about kind of the state of design at MIT and the endless potential for design at this fine institution. And I thought back to my early days, as an undergrad here, in Course 6-1 as a nerd. Anybody not MIT affiliated here? Okay, for those of you who are not, 6-1 is double E, can't spell double geek without double E. Okay, that was me. And I sought out kind of design opportunities on campus. Visual design classes through architecture. I did my undergrad research at the Media Lab where I TA'd a class, fun class called Creative Seeing. A lot of cool stuff. But now, today, you see that design has permeated so many classes, centers, programs. It's just phenomenal. And the future is so bright. Just so exciting. And it's gone across engineering, sciences, and entrepreneurship. Now, after grad school, as Roy said, I got into a career in product design, okay? Pumped out millions of, toys and electronics and appliances, and super fun, successful products. But then, something kind of nagged at me. Like, I would be thinking, am I making enough impact? How much of the impact I'm making is positive impact on the world? Okay, that's always kind of sitting in the back of my mind. And then 16 years ago, I moved here for my wife's job from LA, okay? And I started teaching or helping with design classes, primarily in mechanical engineering here, and got to meet these phenomenal students who are so passionate about their work, about combining design and engineering to solve problems in the world. They were working on devices to help the differently abled. They were trying to alleviate poverty. They were developing clean water systems for different parts of the world. And it just, it was amazing the mission they had, the commitment they had to that. And then 5 years ago, I was presented with the opportunity to join MIT full-time to lead the IDM program, as Roy mentioned. And I jumped at that chance because I felt like now I could kind of commit myself every day to working with these wonderful students. And my mission became to support their missions to improve the world. And that really changed my life, and maybe redeem myself for creating, all this landfill with my consumer products. But so good to be here. Now, the class projects are phenomenal, right? But to make real impact, we have to go beyond academia, from the classroom to the world. And that's what we're here to talk about today. So I've recently had the honor of meeting the pioneers you'll be meeting, who've combined research and design from MIT to make real impact in this world. So today we're going to start with the vice captain of MIT's solar electric vehicle team. That's Maria Aguiar. She is just a second-year student in materials and science and engineering. That's course 3. Okay, we're going to test you later on these numbers. This solar electric vehicle team is entirely student-run, which is pretty special. It's all undergrads under the Edgerton Center. Edgerton is devoted to hands-on learning at MIT, and they make road-legal solar vehicles to race in the American Solar Challenge and beyond. So I know something about student-led teams. My son in high school is part of a student-led robotics team. And it's not easy, okay? It's chaotic sometimes. And they kind of make it work, but it's so rewarding and they feel so empowered. But I know the MIT solar team is really doing phenomenal work. As a little teaser, I'll tell you that they're really crushing it. But I'll let Maria tell you the details on that stuff. They provide their members with the opportunity to learn, design, manufacturing, project management across many fields. Their members learn to integrate different systems together. And I know through working with a lot of teams that integration can be the hardest thing there is, taking all these different components, electrical, mechanical, et cetera, putting them together to problem solve. And I remember as an undergrad, James Warden was a student in the 80s, and he started building solar vehicles here that led to this team. Now with over several decades of building single-occupant vehicles, the team's now transitioning building their first multi-occupant vehicle called the Gemini, appropriately. And I had the pleasure of visiting one of the Edgerton labs where I saw the composite shell for that. And it looked so phenomenal. I wanted to climb inside, but Kim Vanderveer, the Edgerton director, would not let me get inside that vehicle. Good for them. Okay, so this vehicle, Gemini, shares a lot of features with regular cars used today. And it's designed to show the promise and functionality of EVs, especially those powered through unconventional means. The team also does a ton of outreach, spreading the word about renewable energy and STEM education. So let's welcome Maria Aguiar to the podium.
All right. Hello, everyone. Thank you so much, Tony. And thanks, everyone, for coming. So, as you said already, my name is Maria. I'm the vice captain of the MIT Solar Electric Vehicle team. And we're a student-run build team, and we design, build these cars by hand, and then eventually we race them. So we're going to explore how we approach sustainable design, not just through the cars we build, but through the skills and lessons that we learn along the way. So a little more about us. We were founded in 1987 by James Warden under the Edgerton Center. And the Edgerton Center at MIT is dedicated to expanding hands-on and experiential learning for students, especially undergrads. And the Edgerton Center houses several build teams such as ourselves, the MIT Motorsports team, the Rocket team, and a variety of other build teams that, much like ourselves, have an ambitious project that they want to complete within a year or several years, and they bring several people or many people together to make that a reality. So what we do specifically, we have these build cycles that are usually 2 to 3 years, where, again, we design, manufacture them by hand, and then we take them to a 2-part competition, which I will elaborate on further. But our goal with these cars is to apply whatever we learn in the classroom, all that theory, and learn by doing, and learn through trial and error. So more details about this race that we take our cars to. So the first part of this race is the Formula Sun Grand Prix. And what this is essentially a track race. But before we can even get on the track, we need to get through a lot of safety inspections. We have these inspectors look at the mechanical and electrical systems and many other parts of the car to ensure that they're safe. Because there is a driver. We have a team member inside of the car that's driving this on the road. So we want to make sure that our cars are safe. And then after we pass our inspections, we can then move on to the racetrack part of the race. And this is really different from a typical car race that we're probably used to seeing, where instead of being rewarded for speed or acceleration or how fast your car can go, we instead focus on endurance and how quick or how quickly and how far we can go, and how reliable our car is. That reliability and endurance is one of our priorities with designing a car. So once we complete as many laps as we can, where we're judged on the amount of miles that our car is able to run, we can then qualify for the second part of the race, which is the American Solar Challenge. And as the name suggests, it is a truly challenging part of the race, of these two parts, because we take the car out of this controlled environment, out of the racetrack, and take it onto real roads, onto state highways, where we drive alongside normal cars and semis, and it can be a little scary sometimes. And this is where we actually go for 7 to 9 days on essentially a road trip across the country. And the purpose of this part of the race is to show just what solar power can do for cars and how it can compare to a typical gas-powered car. And there's lots of things that solar power kind of brings to the table that you wouldn't see with a gas-powered car. And we can explore that through our previous car, which was Nimbus. So Nimbus raced last summer and the summer before. And we're happy to say that Nimbus actually won both of these races. For the first time since 1995, our team earned a title with this car. And she's truly special. It is a single occupant vehicle. You can see this bubble on the right-hand side. That's where the driver sits. And this car last summer drove nearly 2,000 miles from Missouri to Idaho, completing various loops and additional miles along the way. And the cool thing about this car is that on a sunny day, driving at 40 miles per hour, you can go completely energy neutral. What that means is that any energy you spend from driving at that speed is immediately made up for because the car is passively recharging as it's driving with the sun's rays. So as long as there's sun out, Nimbus could go basically forever. And compared to a gas-powered car where you have to worry about, oh, what if I run out of gas? Or I need to stop at a gas station along the way? Or what if I get stranded on the side of the road? Well, with Nimbus, it's good to be stranded on the side of the road because you can just park it and let it charge. And after you wait a bit, you can just go on your way. And that's exactly how we were able to drive such a long distance, simply by stopping on the side, letting it charge for a bit, and moving on. So after we raced Nimbus and we had our success, we didn't want to just stop there. We wanted, moving on to a next car, to make improvements and to address the practicality and the functionality of these cars. So we had some questions about Nimbus. For example, how can we make the charging better? How can we make its range better? Because when we charge Nimbus, you can kind of see it here at race. We prop up the array so that it's aligned with the sun to get as much charge as we can. It's difficult when you don't have sun outside, or if it's cloudy, or if it's rainy. So we wanted to design a car that had better range, and so that we could store enough power in case the conditions didn't become ideal. Another thing is that Nimbus, as you saw before, is single occupant, so there's just one person there, whereas most cars that we're used to seeing today have at the very least 2 seats, and most SUVs now have 4 or 5 seats, and then we have even bigger cars. So there are also features that aren't entirely necessary in a car, but they're still valued a lot. For example, sound and music systems, navigation, Google Maps, Apple CarPlay. They're not super necessary, but they're seen in nearly every car that's on the market today. So we had all of these questions, and we had all these challenges after Nimbus, and we wanted to try something different. And this is where Gemini comes in, mentioned earlier. So this is a recent model of what the vehicle looks like. It's our first multi-occupant car, which means it has a driver and a passenger. And we added multiple changes to sort of address the questions that we mentioned earlier. For example, we're going to have a larger panel area. That means we're going to have more solar cells on this top of the car. You can kind of see the tail extend to the right. All of that is panel area. And then we're going to have a much larger battery, so that extends our range. And so if the conditions aren't ideal all the time, our car can still keep going at higher speeds. Another thing is that our compartments for the driver and the passenger are a lot bigger. We don't just have a little bubble for the driver. We have a lot more space and legroom that you can compare to a standard car. And then another thing that we're trying new is an infotainment system. So what that means is now we're developing a dash system that's going to have music and Apple CarPlay and Google Maps and weather data and all of those fun features that you'd see on the dash of a car today. So with Gemini, we're hoping to address the questions of practicality. So how do we make this happen? Because we have a team of people, and this is an ambitious project. And if we want to race by the summer of 2024, so not this summer, but the next, we kind of have a timeline to deal with. So how our team does this is we're divided into sort of 3 subsystems. The first one is aerodynamics and composites. So they deal with making sure that they can minimize the amount of energy it takes to move Gemini forward. Because with a typical car with combustion, you have a lot of energy that allows it to go forward. But with us, we're running off of the same amount of power as like a toaster. So it's a little difficult. And we want to make sure that we save as much energy as possible and minimize the drag, make sure we have a lightweight car so that the motor doesn't have to work as hard to push a lot of pounds forward. So aerodynamics and composites, they work on not only designing a smooth and sleek car that looks really different from a typical car, but also working with lightweight materials, composites, to make sure that we have a car that can just cut through and go pretty fast. And then we have our mechanical system. So these are systems that you'd be more familiar with a typical car, like suspension, steering, brakes, all of that. And mechanical ensures that the car can roll smoothly and it can stop safely. And so then once we combine mechanical and aerodynamics and composites, we have a carriage. So it can just roll forward. But we need something to propel it, and we need energy. And that's what the electrical team specializes in. So these members work on the motor, they work on the battery, they work on the array. They make sure that the car has energy for this carriage to become a car that can zoom on a racetrack. And all of these subsystems have projects within them that team members kind of choose and work on, no matter their experience. And so with these projects, we design everything ourselves, manufacture ourselves, and then make sure that we integrate together. So with Gemini, we're actually at a really exciting stage where we're doing manufacturing right now. So on the upper left, you can kind of see an image of our aeroshell. Over January, during our independent activities period, we went to a boat shop in Maine and spent 2 weeks handling composites and fitting them to molds to make this curvy looking car, this aeroshell. And you can see people for scale. It's quite big compared to Nimbus, for example. Right now, these photos on the right and on the lower left, these are our chassis panels, which we're working on right now. So the chassis refers to sort of the skeleton of a car. So all of the important components are attached to the chassis, and the chassis is what really bears all the forces of the road when your car is driving. So we want to make sure the chassis is strong, lightweight, and we put it all together by hand. So here's some photos from the process. And then once you fit the chassis in the shell, you can attach all your mechanical components, you have the carriage, then you add all the electrical components, and boom, you're ready to race. So that's sort of what our timeline's looking like. And it's really exciting because all of this we learn from each other, and we learn from older members. This is all knowledge that we pass down throughout the years. And even though we're a relatively young team, we're mostly freshmen, sophomores, and juniors, we still teach each other what we need to know. And that's one of the things that we're super proud of as a team. When I joined the team, I didn't really have any machining experience. I didn't really do robots. We do have a lot of members who have worked with robots in high school before, but a lot of us didn't have that experience before. But with our more knowledgeable teammates, we're able to learn how to become better engineers, and we're able to gain those important skills. And because we're sort of inviting to everyone in the sense, we have a really diverse set of teammates. We're happy to share that for the past 3 years, our team has been predominantly female-led. And we think this is pretty cool because often this sort of diversity is starting to become more prevalent in industry, but it's not all the way there. And this team, this bubble of inclusion is really exciting, and we learn a lot through that. Another thing is that being in a solar-powered car team, you have a lot of people brought together who are passionate about sustainability, whether it's with electric vehicles or beyond. And all of these people gain important skills needed for the real world. Because balancing classes with all of the things related to the team is difficult. With a team, we need to worry about recruitment or spending or fundraising or project management, in addition to all those strange and difficult engineering questions that aren't necessarily straightforward. In our classes, we have our homework having typical question and answer direct responses. But here, we gain our answers by doing, by building, by trial and error, by seeing what works and what doesn't, and by passing down the knowledge as best we can. So by doing this, we're able to prepare for a lot of sustainability-related projects outside of the team. So a lot of our alums have gone on to work in startups related to electric vehicles. We have an alum now who's working in a startup related to mining sustainability. How can we recycle mining waste and extract useful materials from that? That's another way to address sustainability. And then one of our most recent alums, who was captain several years ago, has now worked on revamping the electric vehicle team, which is another build team that's working on electric motorcycles that are powered by hydrogen fuel cells. So there's a lot of exciting things going on for our team members and what they do afterwards. And then there's a lot of exciting things going on in industry within the solar car world. These are two of the most prevalent examples of solar cars that are going to enter the market very soon or have just entered. There's the Lightyear and Aptera. And in fact, Lightyear was founded by members of or by alums of a solar powered car team from the Netherlands, Eindhoven. So our team is super excited to be in this rapidly evolving field of solar cars in industry. And beyond just the solar car, we're really excited to expand our skills and to gain lessons and to address sustainability in the long run. So thank you to everyone who came, and thank you to the organizers of this event. Thank you for inviting us, and to the Edgerton Center for giving us the space, the resources, the machine shop to do what we can do. And lastly, I'd like to dedicate this presentation to Anita Warden, who recently passed away. Anita Warden was a founding member during the team's early days, and she was actually the wife of James Warden, who founded the team back in 1987. And thanks to James and Anita, we're able to continue our mission, and we're able to build these cars. So we're endlessly grateful to them, and we're grateful to you. Thank you, guys.
All right, thanks so much, Maria. That was phenomenal. Thanks for that story. It's so exciting. I hope to get a ride in your Gemini at some point. I don't know if we can arrange that. Okay, so next up, I'd like to introduce to you Norhan Bayomi. Norhan is the co-founder and chief operating officer of Lamarr.AI. She received her PhD from building technology from MIT last year, and a master's as well. She's also a postdoc fellow at the MIT Environmental Solutions Initiative and lead researcher at the Urban Metabolism Group. That's such a cool name. I'd love to learn more about that, what that is. Her research fuses artificial intelligence, design, and technology to tackle problems in the built environment. I saw her pitch at the DesignX venture accelerator last year, and was just blown away by the innovation in vision. I mean, she'll talk about this in detail, but she has a system that quickly scans the exterior of a building to determine its energy efficiency, and it does it through drones and AI. So amazing. And it's as fast as an MRI scan for the building. I love that analogy. I don't love MRIs, but I love that analogy. Through an automated workflow, Lamarr's technology provides actionable data for retrofit strategies that architects and urban development stakeholders can use immediately. So can anyone guess why the company's named Lamarr? Anyone? Hedy Lamarr. Okay, wonderful. So let's bring Norhan up. Welcome.
Thank you so much for the introduction, and thanks to everyone who came today. This presentation is very special to my heart. Besides, this is the company that came out of part of my PhD. It's also an output of a research project that started in 2016 with a passion of how we can utilize drones for the built environment and how we can leverage the power of artificial intelligence. The main motivation behind this technology initially started with that climate change is posing a lot of risks right now, with more climate effects are increasing in magnitude and frequency every year, and that poses a lot of challenges on the built environment. In addition that, we need to identify how we can invest in the built environment to be able to improve their efficiency within the next coming years. The Department of Energy predict that there would be around 10 million buildings be added in the US building stock within the next 10 years. And these buildings are expected to perform with higher efficiency, but at the same time, we have buildings that are aging and their performance are degrading over time. With climate policies, we see a lot of changes happening on the positive side. So there are a lot of code that have been developed over the past couple of years that would require mandatory reporting for buildings for their energy and emissions. Similar to Local Law 97 in New York and Birdo 2.0 in Boston. The construction market is also heading in that direction, how we can improve efficiency. So 61% of the construction projects that took place last year were retrofitting projects. And also predictions indicate that the envelope retrofitting industry is expected to double in size this year. But the problem on the ground is much bigger. So like I mentioned, 50% of the US building stock is built before the year 1980. And these buildings are currently performing with lower efficiency, and it would require a lot of retrofitting efforts to be put in place within the next coming years. On the positive side, there is a lot of opportunity to save energy by improving these buildings, as by only retrofitting the building envelope, we could save around 40% of the energy used in buildings. However, the process with how we can identify the right retrofitting strategies is right now completely manual. So how it's done right now, it's a completely manual workflow where you have site plans, you hire a building auditor with a handheld thermal camera. Now it's started to change with more use of drones that become more accessible. But the idea that the building auditors start to take these images manually, and then they go through all these images, each one individually, to identify which areas are considered problematic. Also, there are some cases like the picture in the middle that you utilize some very time-intensive and cost-intensive tests like the blower door test, which actually would require complete evacuation of the building to be able to identify where the leakage are, and then finally report findings to key stakeholders. This process usually could take around 3 months for a building of 20,000 square foot, which is a very time-intensive process. After the data collection, the analytical side is still also very manual. So usually the data are handled by building scientists who go through all these data and develop simulation model to be able to give some sort of an understanding what are the right retrofitting strategies and what is the return of investment on these strategies. And that also is a time-intensive process that does not scale to the current market need. So what we developed in Lamarr is basically we wanted to understand how we can leverage the power of drones and the automation with AI, similar to give your building an MRI scan, which is like the analogy that we have identified through the research, because looking at these images is basically looking at an MRI scan for a brain where you see the problematic area, but we're not detecting tumors, we're basically detecting anomalies. How our technology works, so our technology consists of 3 key components. The first one is the data collection with drones. So over the past years, we have been developing the right flight path that are suitable to collect the data with RGB camera and infrared camera. So we do 2 flights separately. And then our proprietary computer vision and machine learning model basically identify where these anomalies are and classifies them. So this is the innovation in using computer vision, that we collected thousands of data that were labeled by building scientists who are expert in that space. And then we tested the performance of the model to identify that the model can accurately predict the classes of each anomaly. And then finally, the most important step, that these anomalies are translated into geometry that are registered to a digital twin that could be directly integrated into building simulation models to identify the right retrofitting strategies and evaluate return of investment on these strategies. So right now, our service kit consists of 5 key components: flight planning, data collection, image processing for both RGB and infrared data, geometry construction from photogrammetry, and finally, energy modeling. I'll just show you a quick, this is a video from one of the flights that we did. We worked with community groups in New York. We also work with the campus facilities in Georgia Tech and MIT. This is one of the buildings in Georgia Tech that we tested the entire workflow to identify how fast or accurate we are compared to the traditional methods, up to the registration of the anomalies, which is the geometry you see here. Also, we have been developing kind of a prototype of a software that could be used by regular homeowners who are interested to inspect their buildings and identify where the problematic areas are, where you can just capture any thermal camera with even an IR flare extension for an iPhone, and you can upload the images directly to our software and can tell you exactly in each image where are the anomalies and what type of anomalies this is. And this is very fast, so it can process 1,000 images in 2 seconds. These are some of the expert study that we have done. This is one of the data that we collected in Georgia Tech, where we validated the model performance using expert opinion to identify how the model can accurately predict. And right now, our model can predict the accuracy with 89%. So with this process, we basically cut down how it's done right now. So like I mentioned in the beginning, it could take around 40 to 20 days only in identifying the right building auditor, up to additional 50 days to do the data collection, and just to deliver some information within 2 months. With our technology, we cut down this process, and basically we can cut down the entire process into 1 week for a typical building of 10,000 square foot. So through these pilots, we have identified and confirmed that our technology can save around 85% of the time spent in a traditional building audit. It's also much cheaper. So it's 90% cheaper compared to the traditional building audit that's been done right now. But most importantly, we are safer and more accurate because we're using drones and we're cutting down any kind of safety concerns that building auditors might face in high-rise building or even other conditions. So for our competitors, we are at the top of the autonomous processing compared to these 3 components, which is the aerial data, thermal inspection, energy modeling, because our software kind of integrate all these 3 components in one single platform, and it's fully automated. How we have been looking at our revenue model. So right now, we're more on the subscription-based model for large property management companies who are our key clients, where they can collect the data and get diagnosis more on time, and then can get some recommendations on what type of repairs could be done, the return of investments on these repairs. Also, some standardized reports on code compliance requirement. Our next step is transitioning to do-it-yourself market, so working directly with homeowners using the Lamarr app, which is currently in development, where people can capture any kind of imagery with FLIR, mobile camera, or a handheld thermal camera, not necessarily drones, because our model also works with handheld data, and they can get some repairs on what type of material that they could use to identify their building's performance. So this is just an example of one of the projects that we have done. This is actually our first client that we have worked with, which is a property that we inspected 13 buildings in Tampa, Florida. And as you can see, these model here, basically an output directly from the computer vision and AI that can tell you exactly which windows have leakage in which floor and which side of the building, and also where are the locations of any missing insulation. And we use that information for thermal energy modeling, which is the table you see on the top, where we can identify how much HVAC energy use saving that you can improve by tackling these anomalies. So with this project, we identified that this technology could be also very useful for decision making, because if you have a property of 20 buildings and you want to see which building that you want to prioritize in your intervention, you could also benchmark buildings against each other with respect to anomalies, areas, and number of occurrences in each one. And we have identified through this project specifically that could be some group of clustering of buildings that are considered performing well, and others that are at the edge of lower floor efficiency. So this project was particularly interesting for us to showcase, because these are the same building that were constructed by the same contractor, the same construction company. They are situated in the same setting. So we were wondering what really caused this large deviation between some buildings are at the top of lower performance and some buildings are performing much, much better. So that goes back to the climatic factor and how much each building is exposed to sun and different situations, and also the use of the building and the operation. So our use case actually cut down the time that would spend for a building like this, a property like this, from 6 months, and we completed this in 1.5 months. It was a very interesting project for us because we took the technology from the research project and we wanted to understand how we can make it an actual product that people can use. And that was a very good exercise for us to really understand how we can automate, how we can improve the output, what does the data look like, how the client could actually use the data. So that was a very interesting project for us. So this is just some of the accelerator program that we took part in. We won the US Department of Energy American-Made Challenge last year with another robotic company called Flex, where basically you take the information from our technology and there is a robotic arm that go inside the wall and basically do the insulation repair real time. Our team is very diverse from building technology, urban analytics, machine learning, and computer vision. And we believe that we came together with the right skill set to tackle this problem that we're facing. And this is the same team that started the research that was funded by the Department of Energy 6 years ago. Right now, we have four employees full-time. 2 of them are actually MIT fresh graduate who joined us during the research and are continuing to work with us. Just finally, I want to say, like, we named this company as a tribute to the actress Hedy Lamarr. She's an inventor of the signal hopping technology, and some of you who are not familiar, she didn't gain any credit for her technology invention during her lifetime, so we are dedicating this company to her legacy and all inventors who didn't gain prominence during their time, especially women. So we believe with our technology, we can revolutionize how building performance inspection are being done right now. So thank you so much for listening, and happy to take your questions after. Thank you.
All right. Thanks so much, Norhan. It seems like science fiction, but it's real. And when you get the home version ready, let me know. I've got this old Colonial that could probably use some help. Fantastic, thank you. Okay, and now for our final presenter, Dan Sweeney. Dan is a mechanical engineer, research scientist, and lecturer at MIT's D-Lab. He's leading biomass fuel, cook stove, and air quality research. Biomass fuel is like stuff made from organic materials, plants, wood, crops, waste. And the D-Lab is a phenomenal program. Our program was housed in D-Lab for a number of years. I got to know Dan and his colleagues and the students, just a fantastic group. I saw a lot of Dan's prototypes lying around of his cook stoves and stuff. What they do is they're passionate researchers, educators, students focused on innovating through designing with communities in the developing world. And the emphasis on the with versus designing for is important. He'll get more into detail on that. It's in collaboration with organizations, social enterprises, and serving their communities for household energy products and services globally. He did his PhD at the University of Utah, after which he moved to Sweden for a Fulbright scholarship focused on development of advanced processes for converting biomass residues into energy and fuels. And apparently you did cross-country skiing across the frozen Baltic Sea?
Occasionally, yeah.
Is that a thing?
Yeah, like the roads were impassable, so we had to
sounds amazing.
Ski to our lab. Yeah.
Ski to the lab, okay. He's active in the International Standards Organization Technical Committee on Clean Cooking Solutions and was a lead instructor for the 2016 International Development Design Summit on cook stoves in Kampala, Uganda. Apparently, he just got back from Uganda and had like a 62-hour travel. So if he's looking a little, no, you're looking sharp. It's good. He's from northern Colorado, where his family has a small farm. He loves rock climbing and folk music, and he's going to share a couple of case studies with you today. Dan Sweeney.
Cool. Thank you. All right. Sounds good. Hello, everyone. I'm Dan Sweeney. Thanks, Tony, for that great introduction. We're going to get a little bit lower tech compared to the last presentations. Those were really awesome. But I still think this is really cool. And is this all set up? So we're going to talk about what's cooking at MIT D-Lab. I do a lot of work, as Tony mentioned, on cook stoves and the fuels that you use to cook, especially in low resource communities. D-Lab works mostly in developing countries. So in my talk, I'm going to focus on a couple of stories about some projects that I'm working on right now with students. We're going to take you mainly off campus, so I'll show you kind of how those are working. Like Tony mentioned, I grew up on a farm. There weren't a lot of other kids around. I discovered fire at a young age, and I was kind of a pyro. Don't worry, I'm safe about it. But when I found out that D-Lab was looking for somebody with some background in combustion and fuels, I was really excited. So I joined the team about 10 years ago. If you're not familiar with D-Lab, we work with people around the world to develop and advance collaborative approaches and practical solutions to global poverty challenges. We think a lot about who's on the design team. Here's our founder, Amy Smith. She's working with a group, I believe this is in Honduras. And one of our longtime partners, Carlos Marroquin, is there. Then I'm not sure what they were making in this picture, but they're using a lot of locally available materials. So you can see bicycle parts, which you can pretty much find all over the world. and they were making some agricultural tools. So that gives you a little bit of a flavor about what our work, our team members look like. So we think about design in 3 ways, and as Tony mentioned, we really try to include local community members on the design team. So as opposed to design 4, where all of us are spending a lot of time in our workshops and our labs designing technologies that we plan to introduce to the world, we integrate closely with the community. We invite users who live within the community or other stakeholders in that area to be a part of the team. So if you take a D-Lab class, at the end of the semester, we will spend a lot of time during the semester working on prototypes, learning about the context of designing technologies for people in low resource communities. But after that, we get out into the field. So during the January break and during the summer, I regularly accompany student teams and researchers to go to the field. So here's actually day 1 of one of our trips to Uganda to work with a community partner there, a social business that's making alternative fuels for cooking, household cooking in Uganda. So that looks a little bit different than what you might expect a regular MIT class to be doing. What we're doing here right now is we're digging our hands in deep to a big pile of what we call char. The team in Uganda made this char out of peanut shells. So they used the residue from agriculture that otherwise goes unused. They converted that into char by firing it in a low oxygen environment. And now what we're doing is we're mixing it with a binder made from a local root vegetable that makes a really sticky porridge. Then what they'll do is they'll press that into a fuel, a little briquette, kind of like what we barbecue with, and then take it out into the market for sale. So I'm not going to talk about this project. There's actually a TED Talk Amy Smith did long back where you can learn more about it. So here's a graph, and I won't go into a lot of detail, but this kind of, I think, summarizes well why we should think about household cooking and why household cooking plays such a big role in the energy and sustainability scene in rural villages especially. So what we're looking at here is a snapshot of energy supplies and the end uses. And this pertains to a rural village in West Africa. I think this was in Mali. This was some colleagues at ASU who did this research. I think it was really cool because they followed all of these different energy supplies and where they ended up being used over the course of the year. So you can see, there's a little bit of electricity, charcoal plays a little role, petroleum probably for transportation, but whoa, there's a big circle up there for wood, right? And most of that wood goes over into the other big bubble is domestic uses, the major thing being cooking. So this really, I think, emphasizes that sustainability and energy challenges are at the forefront, and the way that people are dealing with those now is largely using wood. I think another interesting thing here is you look at the top up there, you'll see a number, 6,000 megajoules per capita per year. You don't have to know what all that means. But each person in the village uses about 6,000 megajoules. We can compare that. I think I put our figure for the US down below. So one of us represents about 50 of these villagers in terms of our energy consumption. I think that's also really important for sustainability. So that kind of emphasizes our work in the biomass fuels and cook stoves group. We have a small team. There's some of us here today. And here's a couple of our current projects. So a lot of people have focused on this challenge over the past 50 years. This is actually in Guatemala, and mucho gusto nuestros amigos de Guatemala. I know we have some friends here. This is a woman cooking traditionally. She's making tortillas on what's called a comal, I hope I'm saying it right. And she has 3 kind of big stones or bricks that she's placed the comal on top of. This is a very common scene in rural Guatemala and also rural areas around the developing world. People have been working on this for a long time, and they tend to have just focused on one part of it, the cook stove. We do things a little bit differently at D-Lab. So what others have done in designing new stoves, kind of following a one-size-fits-all, right? They design and mass manufacture stoves, maybe in India or China, then disseminate those all around the world in hopes that people will have a better experience when they're cooking. They'll be exposed to less smoke, and they'll use less firewood. So we have a lot of these sustainability goals in mind. But what we've come back and found when you visit those communities again, you often find that people have reverted back to their traditional way of cooking. And my thought is probably that's because the designers, the engineers making those one-size-fits-all solutions haven't really thought about the other factors here, especially the tortillas. So our team at D-Lab, we think that by having users and local business people, local researchers and students on our design team, we will be able to better address the overall picture here and meet the needs of this woman. So let's go to the Himalaya. One of the projects that we're working on now is called Himalayan Home Energy. And I'm going to just share an experience from this project. We took a trip, we took students from one of the D-Lab classes, D-Lab Energy, to a couple of villages in the Himalaya. This is one of those villages in the northern Indian state of Uttarakhand. This is a place called Pata. It's very beautiful. It takes a really long time to get there, and we do a lot of walking up and down along with our community partners there. So this was the team in Pata at that time. On the left, we have some MIT folks, some students. Robin in the red shirt is a master's student. You could actually do a master's with D-Lab if you're interested. I'm right there. We have a couple of Indian academics, a PhD student and a professor. And then the two people standing on either side of me are there's the local leader, the Gram Panchayat. That's the guy. And then Savitri, she's a local women's group leader. Who do you think was the most effective and influential in terms of our design project that we did in Pata? Anybody have a guess? Well, if you were thinking Savitri, then you're right. Even though we came with all these academics, people with big degrees, Savitri has very little formal education, but she lives and breathes these challenges every single day. So what we started out doing with Savitri is she showed us her kitchen. This is what it looks like. She has a traditional stove called a chulha, which is made out of mud and brick. She cooks all of her family's meals on that chulha. You may also notice in her kitchen she has a cylinder of cooking gas. And in India, a lot of even rural families have cooking gas, but it's very difficult to refill. It can be very expensive. The cylinders don't always come back. So Savitri, she really prefers cooking with her chulha, and especially because of the nice flavors that come out. So again, coming to a one-size-fits-all cooking solution for Savitri is going to be difficult. So what we decided to do is meet Savitri in the middle. She had her own ideas about what could make the experience of cooking better for her. And we came with some engineering and design knowledge and an understanding of fire, combustion, ventilation. And so we worked with her together on improving her stove. So Sucheta here is doing what we call a water boil test. Very exciting sounding test. Essentially, we measure the emissions and the efficiency of the stove before and after we do the retrofit. You can see Sucheta was really struggling here, right? This kitchen was very smoky when we cooked with the chulha. So Savitri taught us how to make local stoves. And kind of like when we got our hands dirty with char in Uganda, she brought a big basin of cow dung and some grass and some clay, and our whole team got our hands dirty in that. This was really nice, fresh cow dung. That's the best for making cook stoves. So then we knew a few things about how to improve conditions in the kitchen. And one of the best ways you can do it is like what we do here. If you have a fireplace or a wood stove at home, you have a chimney that takes the smoke out. So we taught Savitri and some of the others in her women's group how to make chimneys. So you can see us here riveting together some sheet metal. Then Savitri and our team rebuilding her chula so that we can fit it with a chimney. And doing over the course of a few days, tweaking that design and making sure that enough of the heat from the fire was going into the cooking, we came up with a neat solution that was relatively low cost, could be made from local materials. And we found that it increased efficiency and the conditions in the kitchen improved so much that even the children and other family members felt comfortable to stay in there. That was one of the projects. I'm going to talk about one more now. And this takes us to another continent, Africa, and in West Africa, Cameroon. This is the cutest part of the presentation. So this project, it's supported through support from the Jameel Water and Food Systems Lab. It's called the Off-Grid Brooder, and it's one of the latest things that we're working on in our group. So what we're focused on here is poultry farming. Do we have any poultry farmers here? Okay. I didn't know much about poultry farming other than, it kind of stinks. There's a lot of feathers, and you don't want to spend a lot of time in poultry farms. But that's something now that I've done, having visited Cameroon a couple times. For small poultry farmers, especially in developing countries, they struggle because the chicks need a heat source when they're very young. So for about the first 2 or 3 weeks, they need to be at a very specific temperature, around 30 to 35 degrees Celsius. If you go above or below that, the chance of the chicks not surviving increases a lot. And so for these small farmers that are raising a lot of chicks, they can take great losses. Poultry farmers in Cameroon are very amazing, interesting people. They actually live in this room with the chicks for the first 2 weeks of the chick's life. They stay in there pretty much 24/7 because they're so concerned about the chicks. They're also concerned about their financial sustainability, right? Their livelihood. Taking a loss on a batch of chicks means that they don't earn income. They won't be able to sell these on the market. And that means they may not be able to send their children to school, a whole host of other challenges that can come from that. So there's a lot on the line with these little birds. The way that most poultry farmers maintain a high temperature in the chicks' room or the environment here is by burning firewood. So you can see a big piece of firewood up there. If the firewood, again, doesn't burn very well, it'll, like in Savitri's kitchen, it'll produce a lot of smoke. That also can be harmful to the chicks. So we heard from a lot of farmers that they take big losses due to smoke or when the conditions got too hot or cold. So we got to thinking, what are some things that we can do to help these small poultry farmers? So we went with a team and we teamed up our D-Lab Energy group and also a local organization called African Solar Generation, really great team based in Yaoundé in Cameroon. African Solar Generation had developed a technology for keeping the chicks warm using solar energy, kind of like the photovoltaics on the Nimbus car. So they used panels. The panels produced electricity. That ran a heating lamp inside the brooder, the box where the chicks are. But the challenge was each one of those systems was about $1,500. And we learned that most poultry farmers are only maybe earning $20 to $30 of profit per month. So it's a long time to pay off. Most of them can't afford it. So we worked with ASG to think about how do we take the solar panels out of the equation. And so Ali and Katana are 2 D-Lab students, and they're talking to a group of Cameroonian poultry farmers that we met. And we introduced a new idea that came from some other D-Lab projects in the use of what are called phase change materials. So that sounds pretty fancy and high-tech, but we found a really cool phase change material locally, and that's beeswax. So what that means is when we heat up the beeswax and we melt it, as it solidifies in with the chicks, it slowly releases heat at about the right temperature that baby chicks like. And it can actually go for long enough that it keeps the chicks warm at least overnight and maybe a little longer. The farmers were really excited. They said, this will be great. This seems safe. We can do it locally. So we taught them how to use thermal batteries. And we built a prototype of an off-grid brooder. So the bottom panel comes off and you put the thermal batteries inside. The chicks live in the top area. This is kind of a small-scale version. The farmers thought it was also really important that they could see the chicks. So we put a window in there. And this project is ongoing. We're working on a new iteration of it, but it's very promising. The main challenge some of you may be thinking about is how do you melt the beeswax? So for now, the initial tests we've done, we use firewood, but we're working on a solution that actually you can use solar energy not to make electricity, but as a heat source to melt the wax. So that's the off-grid brooder, and that's the end of my presentation. Thanks.
Thanks so much, Dan. You've got such an adventure-filled life, to flying around, helping communities around the world. I love it. And I love what you're saying about like thinking beyond the stove, you know, and going beyond the obvious. Fantastic. Thank you.
I'm not a great cook, sorry.
All right, why don't we invite our panelists up front? Okay, we'll do a little more discussion. We'll have a little Q&A. You want your water? Oh, you have water.
Oh, yeah.
All right. Andre Green is also on the solar electric vehicle team. He's in charge of the part of the team that deals with aerodynamics and composites, and he's going to join us for the discussion. We'll talk about, I don't know, 15, 20 minutes or so of discussion, then we'll open up for Q&A after that, if that sounds good. So I'd love to circle back with you. Thanks again for your amazing stories. And think about the theme for today, which is, you know, from the classroom to the world. And I would just love to hear from each of you what that means to you. You know, did you have a feeling when you first started your research that would have impact beyond the classroom, or what kind of impact you imagine? You know, anything you like talking about from the classroom to the world. And maybe Maria and Andre, maybe you all can start.
Yeah, sounds good.
At least for me, when I first joined the solar electric vehicle team, I wasn't necessarily thinking about sustainability. I wanted like a more hands-on project to work on my time here. But as time went on and like semester passed, I realized I wanted to get more into sustainability, and I'm trying to get more involved in that now. Like through my year out for this summer, I'm working on like solar panels and like solar panel efficiency in sub-Saharan Africa. So I'm actually really excited because this work will directly apply to like my work on the solar team and so on. Yeah.
Yeah, I think kind of had a similar experience in that I knew that like sustainability was something that, you know, was important, that research was a big part of that, in at least at MIT and beyond. But when I joined because I wanted to learn. I just wanted to jump in and learn how to use the big machines and learn how to build stuff. And as I sort of gained those skills, I realized just how much I could apply to the real world, and especially, at least right now, I'm studying material science. And so seeing how materials can be used to make a better world and seeing how that's applied to the solar car team, I thought that was really exciting. And so at least for me, like what we're really proud of with the team is that it's not just the car that has the impact, it's more of the people, and it's more of the skills we learn through that car. So yeah, that's my experience.
I'll take that mic. You have this lapel mic. So.
Yeah.
Oh, yeah.
Oh, okay.
Go ahead, Lauren.
So my experience was a bit different. When I went to the PhD program, I had in mind I'm going to be a professor. I'm going to take that route. But it came by surprise that I joined an entrepreneurship class with another team from Sloan, that they were using drones but for a different purpose, for just mapping. And I was just starting this project, so I got really excited about the prospects of how this could be a commercialized technology, going through the journey of building a company and understanding what is the revenue, how you can actually create a product. That was really exciting, and that kind of like the point that changed my mindset to go through the route of having this from a research to an actual product that people can use.
So you don't want to be a professor anymore?
For now,
For now, okay, yeah, that's awesome, fantastic. Dan?
Cool. Yeah, I think for me, so one of the things I really like about D-Lab is the big network of collaborators that we have around the world. And I think a lot of those collaborators, they're not just collaborators on projects, a part of our design team, but they're also a part of our instructional team. So we spend most of the semester at D-Lab in the workshop, in the classroom, in the lab. But when we do get to go take students to the field, I think that's where a lot of the real learning happens. You quickly, all of your assumptions break down, your prototype that you built using the laser cutter at D-Lab doesn't work anymore, and people, they wouldn't accept it anyway. And so a lot of that learning just happens there. I think empathy as well, kind of going and seeing and experiencing how challenging it is to live in some of these communities, and learning about those challenges and working with people to solve them. So I think getting off campus, even though we love spending a lot of time here day and night, it's the real learning happens when we get out.
I was going to ask you, how does that impact your students getting out in the field and doing these projects with the communities?
Yeah, I think it has a major impact. We have a lot of repeat offenders at D-Lab, so they take one class and then they'll end up taking all of them. So yeah, most of the classes are project-based, as you can tell. We love to be hands-on, and so I think, yeah, it has a big effect. We have a growing number of students who've graduated taking a lot of D-Lab classes who have gone and sought out careers in either international development or started up a social business around a project that they worked on at D-Lab too. So,
that's great.
Yeah.
Okay, another question is, there's a lot of research, development around energy, materials, it's, scientific research, engineering. And the theme today is design. So I'd love to hear your take on, the role of design in tackling environmental issues for any of you.
I can start. In our case, I think, I went to the building technology program, and the program is basically oriented how you can design technology to improve the performance of the built environment. But I would say, like, designs also, I encountered design in designing the actual company, how the journey of what exactly is our product, who our customers are, and if this is actually a viable product. So there is the design journey in building a company. That aspect is some sort of like not really highlighted, but it's good to get into the problem knowing the value of what technology that you're providing and the bigger challenges and the bigger impact than just getting revenues or building the company, which is improving the performance of buildings. So I would just take it from the angle of designing the company, the journey that you go through, building the team, and identifying the problem solution fit and all these aspects of the entrepreneurship journey.
Yeah, I know that's a big part of the Design X kind of venture accelerator teaching, right?
Yes.
Taking you through all the steps, not just design, business, making sure your technology is feasible. That's great. Others?
I think or something on solar team that I've experienced is the challenge of integrating different solutions to problems. And there are lots of different environmental problems that are going on in the world right now. I think, or just something to take note is that all of these solutions have to be able to successfully work with each other. Instead of just working independently of each other, they have to work together to solve the problems, so it will be just more effective solutions to the problems. Yeah.
Yeah, I can add a couple things, I think. So I think one part of, it's important to integrate design and design process. We take that really seriously at D-Lab. A lot of times we don't actually know what the real problem is that we're trying to solve, right? So you go talk to Dan, he says it's one thing, then you talk to Betty in Uganda over a WhatsApp call. She says there's another issue, and these student teams are often confused. Things are very chaotic in the beginning. So we think, taking them through that process of, trying to clear the clutter and see through and see what the real problem is that they have to focus on is very important. I think another part of this, and especially in terms of sustainability and in the environment, oftentimes, those of us coming from MIT, the West, or the global North, whatever you want to call it, we have different priorities than what people like SEVT have, right? We think it's, we're trying to solve climate change, deforestation is a major problem, right? Water quality, all these big global challenges. SEVT may be very different, right? She's struggling to, earn enough income. She wants a better life for her kids. She said to us, you guys are coming and talking to us about climate change. Well, look at you, She pointed the finger back at us. Why are we the ones that have to try to solve this? So I think, aligning those priorities, right? And maybe, finding that middle ground that we're able to find with SEVT, doing, these small solutions in individual communities and thinking about how those will eventually scale and, reach a broader audience, I think, too.
No, I totally agree with what you're saying, especially about the problem framing. So often we're given a problem to solve by a professor or a manager, and we just take that for granted without questioning, is it the right problem we're working on, or do we need to reframe it or poke a little bit further?
Absolutely.
Yeah, that's great. Any other thoughts on this one? Another thing I was thinking about was, how can universities or other organizations, help support taking this academic research, this work, and commercializing it? What more can be done in that area?
Yes, I can add something about. Something already that the Edgerton Center is doing is promoting hands-on student engagement, and to get their hands dirty and to work on building things that they enjoy building and to pursue their passions. So I think they're already doing a great job with that. But I guess to promote more of that experiential learning sort of things, and that's really helpful to, I think, the students for learning and for gaining the skills they need.
Yeah, that's great, and that's what the Edgerton Center is all about, right? Experiential learning. We have a whole experiential learning group out of the Office of the Vice Chancellor here. So I think across the Institute, there's a lot of effort around that. Excellent. Other thoughts about that? Commercialization?
I can add from our own perspective is that I believe MIT was very unique in the sense that you get access to all these accelerator programs that they can give you funding, which is very essential in the beginning. But at the same time, the awareness and the knowledge about the business design, which is usually technical people, coming from a research project, you are very oriented towards the technology, how it works, if it's working properly, but you're not thinking how people are actually going to use it, because we're not really educated with the sense of thinking business, coming from engineering school at least. So I think what was useful, speaking specifically for DesignX, which was, I took DesignX twice, which was a very interesting process for me, that you actually learn how to think of the problem from the business side of things, not just focusing on the technical component, but also you can have a really successful product that technically works, but no one can use it. So that's the thing that you learn through these programs, and there are other programs like Sandbox and the Engine that you go through that. But I feel like the landscape here was really pushing that idea of commercializing whatever technology that comes of research, and they actually like to see people commercializing their research. So I think that's kind of the aspect that needs to be emphasized more.
Yeah, that's really key. And MIT has such a great ecosystem for that. There's something like, I heard 80 different groups focused on entrepreneurship, acceleration, innovation here. And you just kind of seek them out, right? Yeah. Like Sandbox and Engine and other ones you mentioned. And just that integration of learning and knowledge between the different disciplines, and how important it is for someone technical to learn about the business side and vice versa, right? It can lead to great things. So I was going to ask you about Lamarr. If everything goes according to plan over the next 5 years or so, what's your big vision for your company, and what kind of impact do you think you'll be making?
First, nothing usually goes according to plan, but our vision is that we named the company this way in addition to tributing the Hedi Lamarr, but we wanted to make this bigger than just one technology, so more advancing on other solutions for the built environment with the respect of mitigating climate change risks and improving access to a lot of rapid technology that could be deployed with drones and AI. So that's kind of the vision where we're heading if everything goes according to plan.
Yeah, excellent. How about you, Maria and Andre? What's your vision for, solar cars? Is that going to be a thing? That's, you showed a couple of that are being produced, right? What do you think is going to happen in that field?
Yeah. Okay. Sounds good. You go.
At least for solar vehicles on the road, or you saw a couple of them on our presentation. But as for the future of them, I think they're more useful as a supplemental technology right now for energy production. But in the future, it may move on to be a primary energy source as solar cell efficiency improves and battery capacity. Just as these technologies improve, we can see more and more usage of them in the future.
Yeah, with our car at least, we're kind of on this trend of towards practicality, and as we're starting to enter this new category of vehicles, well, right now our priority is to make sure Gemini is finished and that she's able to race. But with the car after that, I'm sure that practicality will be even more of a focus. We can add other features like even more seats, more trunk space, things that make these solar cars more viable and more practical. And as the technology evolves with that, well, I predict that the cars can only get better.
Love it, love it. Okay, maybe I have one more round of questions and then we'll go to the audience. Does that sound good, Roy? So, MIT has so many classes that relate to the environment, sustainability. There's a very popular sustainability certificate, and there's a brand new undergrad degree. It's on climate system science and engineering. So what would your advice be to students who are interested in learning more about sustainability and maybe getting into that as a field?
I can start.
Please.
So I think one of the things that would be really useful in addition to the sustainability classes is, I'm not just advocating for AI, but there are a lot of overlap that's happening within even the past year with how AI could be very, very useful for climate change. So I would say for someone coming from a background that interested in computation aspects, how this could be linked to climate change solution, I would suggest explore at least AI classes. There's the Introduction to Machine Learning class, for example. There is another AI class that gives you an overview. So I would say coupling the technical aspect also of how you can utilize computation with climate science.
Excellent. Other thoughts?
I think I would add, at least for any current student or student going in, definitely to, take any opportunity you can to learn, and to at least at MIT there's a lot of opportunities to get training at a machine shop and learn how to use all these tools, or join this build team and do a project, whether it's a solar car or a motorcycle or a rocket, and those are really good ways to sort of gain an intuition for how to design things, how to improvise, how to problem solve. And another thing, which was already mentioned, is thinking of the social impact of the field that you're studying, and taking those classes that really make you question how does what I study apply to sustainability, and how can we use that to make a better world.
Wonderful. And Dan, you just want people to take your classes, right?
Yeah, that's it. If you have energy, we'll get you in a good place. Yeah.
Wonderful. Okay, excellent. Let's open it up to your questions. I'm sure you have some thoughts for our panelists. Who wants to go first? I'm going to run up with a mic. Yes, okay, you're going to make me run. I was backpacking this weekend, so my knees are not doing great. Let's give your name first.
My name is Jimena, and we're visiting actually from a university in Guatemala. And I had a question for Maria and the solar car team. Regarding the challenges that you face when designing a sustainable car, I wanted to know how does the three-part team that you have, the aerodynamics, the mechanical, and the electrical team, how do you come together to tackle these challenges that you have when you're designing a sustainable car? Because I guess it's not easy to get the car working, and not only working, but performing at its best. So how do you face these challenges when you're designing?
Yeah, so you're right in that bringing everyone together is probably the most difficult part about building a car. And I think often our solutions involve communication. So just having every team talk to each other and making sure that they're not in their own islands of designing, that they're constantly talking to each other. And as soon as they have a question, they can bring it up to another team if they sort of need to mesh together later on. Right now, I mentioned that we were working on our chassis. And right before we had those panels cut, we had all the mechanical sub-teams, suspension and steering, come together. And they made the model, and we opened the model, and everything clashed with each other. And the tire, the model tire in the 3D model was inside the chassis. It was a mess. And the only way we could fix that is for someone to bring that up and be okay, this happened, this is wrong, talk amongst each other. And we, at least a lot of members, spent our spring break kind of talking and messaging in these long threads about how are we going to resolve this and how are we going to tackle the issue. A lot of the times, those issues are seen once you start to bring everything together. So we really learned how to communicate and how to talk to each other, which I'd say is pretty important if you're working in a team.
Thank you.
Thank you.
All right, who's next? Make me run to the bottom? Oh, no, right here.
Thank you. My name is Tamana Tadla. I am not an MIT student, but I have a question, like how to initiating like Global South and Global North initiative, which in order to create circular economy for sustainability. That's my priority question I wanted to ask. And then second thing is like for the in order to, because I'm currently doing my master thesis on Global South, how the best way to like creating a strategic partnership between university and an institution globally?
Okay. Yeah, I'm not sure if I totally got the question, but I think circular economy was a part of it. Yeah.
Yes.
And then also the how do we establish partnerships?
Uh-huh.
Okay. Yeah, I'll take a stab at it. I think, I think the circular economy is definitely baked into all of the D-Lab projects and classes and across the campus. I think that's just a big theme that everyone is focusing on. My own work in particular, you know, I showed the photo initially of using waste to generate energy and a material that you can use to cook your food. So we're, you know, very focused on circular economy. I think one thing I didn't think a lot about before I decided to, you know, do this type of work was the importance of people having incentives to do that kind of work. D-Lab does a lot of, I would say, open source or open access innovation or invention. And at the end of the day, it seems that, you know, people need an incentive. They need probably to earn money to help scale those up. And so, yeah, I think that's a part of it that we have to keep in mind, even when we're transferring technology to communities, that, you know, taking that forward in a business is a good way to help reach more people. In terms of partnerships, I'm probably not the best person to talk to about that, but yeah, we have, like I said, a huge network. I mean, MIT has connections all over the world. D-Lab, you know, more at the kind of grassroots level, local organizations, some schools and universities. And yeah, we're open to new partnerships, and if you, yeah, especially people who are bringing some experience and context that our students can take and work on a specific challenge, then that's something we're willing to talk about. Yeah. I don't know if anyone else has something to add there.
Okay, another question for our panelists. Okay.
Jonathan Hunt from MIT. Dr. Bayomi, this is directed to you. Have you looked at municipalities as another possible market segment, as a group that has a lot of buildings and trying to prioritize the efficient use of the funds to retrofit those to be more energy efficient?
Yeah, we kind of like try to explore that route. The only issue with that is, and it's the same thing for any new AI technology, that people want to see that it actually works and it's better than how they currently doing it. So the challenge for us, that before actually going to talk to these people, we wanted to have some sort of like a number of validated pilots that we tested and have a quantifiable measure. Because usually working with municipalities or government entities, it's kind of like a risk factor that working especially with new startups. So that's kind of like our next step. We were trying to build that number of pilots and validated case studies before going into them. But definitely there is a huge value in providing this technology to them.
Thank you.
Okay, another question. Don't be shy. Your big chance to ask our experts about anything. Another one from Jonathan.
This is for the solar electric vehicle team. How fast was your previous car able to go? And then how fast do you think Gemini will be able to go?
Oh, okay, that's a good question. So at least for a race, we value more the average speed, but we're certainly proud of our top speed record. For Nimbus, we remember on a downhill we went at about, I believe if you round up, it was like 73.5 miles per hour. That was on a downhill. So the car can accelerate up to around 60 miles per hour because we have a motor specially used for solar powered cars. But it's so aerodynamic that as soon as you start going downhill, you speed up until the driver is not comfortable anymore. And the driver was comfortable at around 70 some miles per hour. With Gemini, we're not really sure what our top speed would be, but we're going to have, instead of one motor, two motors. So we're hoping that our average speed, at least throughout the duration of the race, will be at least 40 to 45 miles per hour. Yeah.
All right. We can go back to the audience too.
Okay, thank you. Yeah, I had one question. I think that for the three of you, actually, about the relationship between the process of putting things out there and also the actual process of learning. No? So in a way, how the two things are retrofitting and helping each other. And I wanted to know a little bit how that happens in each of your cases, like, because they are actually a little bit different, right? Like, some of you are prototyping, in your case, then you're implementing. Also in your case, you're implementing as well, like Norhan. So can you tell a little bit about that, like how that works, like how there are like some learnings that you take from out there and then you take to the class environment, and also like how, in a way, that generates a culture that you are also like transmitting internally at MIT?
Should I go for it? Okay, I'll start. I guess, yeah, one thing that comes to mind related to this is that there is tension between, learning and implementing in our case, right? A lot of the students and myself, I'm constantly learning every time I go and work with one of our communities. And we have to understand that, the things that we're testing out, they may or may not work. That may actually have a huge impact on people's lives. There was a time when we were measuring indoor air pollution in people's homes. And so one of the PhD students who was working with me, he developed a sensor, basically a black box, right, that is kind of sniffing the air all the time in the kitchen. And the measurements that we made were really crazy, like the levels of particulate matter, like PM 2.5 and carbon monoxide, were to the extent that definitely like these people's lifetimes were reduced significantly. So as somebody who's making those measurements from a scientific perspective, trying to use that information to learn and then develop something better, it was I felt a real contradiction. Like, I really wanted to do something immediately that could help the problem, but I needed the evidence to support that, we can actually, that what we're doing should actually be scaled up. So I think the tension between what a community is experiencing and our process of learning and designing is something we have to be really careful about. I think D-Lab's approach is, doing a great job of vetting community partners, finding really good alignment in terms of our mission, and they understand, that not everything will be a success, and it's a part of that process. So, yeah.
I can echo on the tension point, because we had something similar developing the technology itself, that speculating if it's gonna be useful for clients beyond, if it can go beyond research. So that's kind of like what we learned through two things. The accelerator programs we joined was a good validation that this actually something that we can commercialize, because working on the research, you are very focused on publishing and getting the technology right, and sometimes you tend to forget what is the actual value. So for example, we initially had in mind that this could be not a software, it could be just a hardware that kind of like a sensor that we could link to the drone and process the data on the fly, but our mindset shifted through the entire research project that we want to build the software. And even like who will use our product was something that changed multiple times, and we had to go through this iteration and testing and talking to people, and that's something that comes with the process of commercializing this product. So that was, in our experience, it was useful to really go through that with mentors in the business side of things and teaching us how we can design the customer discovery, for example, who are our key customers. So we went a lot back and forth in addition to the technical component of the product itself.
Those are great examples. Maria, Andre, do you want to chime in on that, or?
Yeah, I could add a little segment, at least speak on like sort of the culture of MIT, where sort of working on design and then implementing that in the real world. While our team focuses more on making sure the car is done and it can race, there's definitely challenges in even getting there. Sometimes there's gaps in knowledge when we're trying to pass down knowledge, because at most we only spend as undergrads up to 4 years at the school. And so sometimes you lose this knowledge on how to do a particular thing about building a car. Or if we're worrying about spending, like how can we try and convince people that solar cars are relevant? And that's one of the most difficult, or maybe one of the most challenging things about building a car, is trying to show that it's relevant and trying to show that these cars do have a future. And now, like, it's becoming much more visible as those cars that I mentioned are starting to enter the market. And so it's exciting and it's challenging, but that's why we're here.
Thanks for sharing. All right, other questions? Yes.
Thank you. Can you hear me? Yeah. So I'm Catherine. My job is to invest in climate technologies and infrastructure projects in emerging markets. And I was listening to the building team's product with a great interest. You just mentioned about customer discovery, and I was wondering whether you would be also looking at markets outside of the US. I get a sense that since you studied in the US, you just inherently look at the US as the universe and then try to find the customers within there. But in emerging markets, there's as much or even greater need for green and sustainable buildings. And actually in the US, you have competitors and your solution might be incrementally better solutions. But if you go to emerging markets, since there are that many other options, you might be actually disruptive solution and make a greater impact. So this is a question that I know when you do customer discovery, whether you be also looking at market outside of the US. I would actually encourage you to do that, given how what I see in the emerging markets. But I also wanted to understand whether you have gone through that sort of a thought process. Thank you.
Yeah, that's actually a very, very valid point. That so me and Tariq, the two main co-founders, are from Egypt, and we were really interested in implementing this in Egypt. But the main challenge that we faced, even in the Middle Eastern region, is the lack of regulations for drone operation, which was one of the main challenge, how we can collect the data. So that was one of the things that we wanted to explore, how we can redesign our product to work with regular handheld thermal camera with some sacrifice from the accuracy, of course, because you'll not be able to capture with high accuracy like flying a drone. So we try to explore that. But going into the accelerator programs, I just want to go back to that point again. It's usually better to zoom down who is your initial beachhead market, especially for new startups, because that helps you to identify how you can generate revenue, how you can develop the product. So in our case, even we're not looking at the entire US. We're mainly looking at 2 cities, New York and Boston, because these were kind of like our core potential for large building stock that would require retrofit, and the landscape of regulations also helps. But of course, on the bigger aspect of the vision, that we would like to expand to other markets. But we decided to focus on where the landscape works best for our technology.
Thanks for your question. See, we're making connections with investors now. One more question. Last question. Yes. All right.
Hi, I'm Lisa. Can you hear me? Yes? Yeah, okay. I'm a little bit curious about the business model in Lamarr, because I heard that you're using subscription models. And basically, I wanted to know, why did you decide to use this subscription, and is it going to change if you're going to make like Lamarr for individuals? Because I think that AI is a very useful tool, but as knowing that it is a bit more cheaper than the other ways people make these things, like why subscription, and is it like sustainable for the long term?
Yeah, so we didn't start with subscription. We were more of like a service-based model, so doing by project. But then when we changed our customer, because initially we thought that our key client is the building auditor who would like to use that technology. But then when we changed to property management company, after we did the market research and the customer research, we identified that it would be best to develop this package of subscription for a company that owns like 100 buildings, and usually they would require to do this like once a year, but they have large building stock. So because we're also running our model on the cloud, so there's an additional cost from our side for the cloud processing that we wanted to account for. So to be more profitable or reasonable from business side, we thought that subscription would be best for us. And we can also tailor within our subscription model. We have different packages. So the technology itself is divided into 3 different packages because each client has different needs. Some people are not interested in the energy modeling, for example, in which we encountered. So they only want the image processing, which is like, just tell us where are the problem area, and that's it. We are not interested in the energy because they have their own in-house workflow. So that was kind of like the logic why we did the subscription also. So this is kind of like something we explored through the process.
Thank you.
All right, thank you all for the fantastic questions and for hanging out with us this afternoon. Thank you, Dan, Norhan, Maria, and Andre for spending the day with us and just sharing your insights. It was a great time. Thanks.
So, yes, thank you, certainly, all of you. Also like thanks, Tony, for moderating the event, and thanks all of you for coming. So, as I said, this is the first time that we organize something with the Boston Design Week, but it will not be the last. And actually, in fact, next week, also on Wednesday, also at 3, also here at the MIT Museum, we'll organize a second event as part of the Boston Design Week, in that occasion titled Tomorrow's Designers Designing Today. And what we will have is some of the design fellows that we have at MAT. So today we have some graduate students from MIT, and next week we will have also graduate students from MIT, but in that occasion, like already linked to the Morningside Academy for Design. What we do is, like every year, we give 10 to 12 fellowships to people that is interested in doing design projects, and we collaborate with them, help them create an environment to discussion, talking, etc., in which like this type of design projects can be developed. So they will be here. You are all welcome to come again and join the event. So finally, to close, I would like to thank again the MIT Museum for their collaboration. I would like to thank the Boston Design Week. I would like to thank also the MIT AV and BP services for helping us with all the technology supporting the conversation. And finally, again, I would like to thank you, all of them, for coming here and talking to us today. Thanks, guys.